Assalamualaikum. Welcome all. I'm going to solve this problem. Okay, it's from book 26.7. A spherical ball of solid naphthalene. Okay, is diffusing in air, still air. So air is not moving. Air is still. So you have a sphere. So a sphere will diffuse in radial way, right? So this is a sphere. So it will diffuse in this direction, like this. Is all spherical, isn't it? So this is R. So it will diffuse in a spherical direction. So diffusion is taking place. Now what we need to find, I have just simplified this question. We are not doing this. We're calculating the initial rate of diffusion in mole per unit time. So usually we say WA. Okay, how much it will diffuse from at this surface. So mole per unit time we need to find. So as you can see, this is a spherical, so we have to see the equation, differential equation for spherical coordinate, isn't it? So if you go back to your slides, you can see here spherical coordinate. Okay, so there's no diffusion in theta direction, no in phi direction, there's no reaction, it's only diffusion, isn't it? No, this is steady state, so this dc dt will be 0 also. So you end up with this 1 over r square d, this term equals to 0. Okay, so what we get from differential equation is d over dr r square nar is 0. Okay, so this means that this term inside is constant, that's why the derivative is 0. So r square nar equals constant. At surface of this one of the boundary we have at r equals capital R, this is the surface. Okay, here. So at r is equal to capital R, at r equals capital, this is at surface, so r square n a r. Okay, this is flux at r equal to r equal constant. Okay, so now if we just multiply this by 4 pi, okay, and then okay, this also we can multiply by 4 pi. So this term area times flux, flux is mole per unit time per unit area, and you multiply this with area, this becomes smaller mole per unit time, so which is WA. Okay, this whole term is constant. Okay, that is WA. So WA equals 4 pi times C. So C is basically 4 times C. So your r square NAR was constant C. So this we can write at WA divided by 4 pi. So basically we get NAR with respect to R, which is WA divided by 4 pi R square. So this is the way flux is changing with R. So we get this relation how flux is changing with R for this sphere. Now let's go to general equation of flux. NAR equals, this is diffusion part, DAB dy A over dr plus ya mole fraction NAR plus NBR. Okay, what we have here, we have the naphthalene is diffusing in air. Air is still air, which is B. This is A. This diffusion is from here to here. There is no movement of air. So NBR is 0. Okay, NBR is 0. So this is like unimolecular diffusion. So now if you rearrange this equation, you get basically NAR is there. So NAR 1 minus YA equals minus C DAB DYA dr. Okay, so basically it will lead to this DYA over 1 minus YA equal NAR okay, NAR dr divided by C DAB, and we have a minus sign here. Now we know that NAR equals WA divided by 4 pi R square. So next step, we will integrate this dya over 1 minus ya equals NAR is or WA 4 pi R square. Sorry, this R is constant. The variable R is small r, right? dr and CDAB is constant here. CDAB. Okay. So now we need to differentiate this. Integrate this. Okay, let us write in simpler form. The boundary conditions here. Okay, we'll come to this WA over CDAB times 4 pi and this integral of dr over r square. From where to where we integrate? Okay, the bulk here, it is diffusing, and this is R, this is R. So diffusing tank from here to the bulk. Bulk is away from the surface. So that is like infinity. So we integrate from R to infinity. And then y is 0 at this point, and at far from the surface there is no a here, so this is 0. Okay, so what do you have here? If you integrate this term, you will get ln 1 over 1 minus ya 0. Okay, applying the limits also. This one wa divided by c dab, and then dr over r square, this becomes basically minus 1 over r to infinity. Okay, so 1 by infinity is, and we have 4 pi also with this. So wa, the rate of diffusion, mole per unit time, this will be 1 over infinity 0 and 1 over r. So this becomes basically 4 pi c dab. Okay, this times ln 1 over 1 minus ya 0 and 1 over r coming from integration. Okay, 1 by over r will come in this part. Sorry, this part, right? So wa, this r will go there, 1 over r. So this is r multiplied. So wa becomes basically 4 pi c dab r 1 ln 1 over 1 minus ya 0. This is all ln. Okay, so depending on dab, depending on concentration, total concentration, and this is the mole fraction of a at the surface. Okay, the total concentration, you can get it, total pressure given P over RT. dab is given to you, R is the gas constant, ya0. How to get the ya0? At the surface, this is in equilibrium, right? So total pressure is 1 atmosphere. The vapor pressure exerted by here at this point is basically given to you. The naphthalene exerts vapor pressure of 666 Pascal. Okay, so how to get ya0 at the surface? Ya0 will be the vapor pressure divided by total pressure. Okay, which will be 0.006. 0.0066. Okay, so if you put all these values, you should get wa equal to, okay, I don't have the number here, I leave to you to get the number. Okay, so that will be mole per unit, everything in time, so it should be per unit second. So this one example, diffusion, spherical case, okay, unimolecular. So hope it is clear, and please practice, and if you have any question, get back to me.